We should also be familiar with the graphs of exponential growth functions. In the previous video, we presented y equals 2 to the x power to be an exponential growth situation. And we could sketch this on our calculator by going to y equals and then putting 2, raising that to the x power, and hitting graph. And right here, this is how that type of function would behave. You're seeing how the values are growing rapidly. We also could do a sketch here, and we know from our chart here that we have a chart of values, only select values, but we have a good understanding here that if we have y equals 2 to the x power, if x is 0, y is 1, so that would be right here, and then if x is 1, y is 2, because we're doubling each time. If x is 2, it's going to go up to 4, so let's say that's right here. And so this is going to be the nature in which the graph behaves. It's not a straight line because it's not linear growth, it's exponential growth. Yes, your x values are steadily increasing, but your y output values are rapidly increasing. In the same way, we could take a look at a situation of exponential decay and how that graph would look. We have a situation where y is equal to 1/2 to the x power. So I'm going to go ahead and to y equals, and I'm going to erase the equation that I just used, and I'm going to put 1/2 to the x power. I'm going to put 1/2 in parentheses, which is important. Raise that entire fraction to the x power, and graph that. And now we're seeing the way that this graph would behave. You're seeing again, x is steadily increasing, but your y values are rapidly decreasing. There's no linear growth going on here because it's an exponential situation. And we could take a look at our chart that we had for that same function. When x is 0, our y was 1, which is a commonality between the two of these graphs. They both had 0, 1 as one of their points. However, in this situation where we have y equals 1/2 to the x power, when x is 1, y comes out to be 1/2, which would be right here. I'm going halfway up the box. When x was 2, y was 1/4, so I'm going to go 1/4 away up the box. When x was 3, you had 1/8, so we're getting closer. And this is the way that this graph would behave. An important thing to realize in both of these situations is that the values, the output values, get very close to being on the x-axis in both of these situations, but they will never actually touch the x-axis.